Let's look at UniquePaths problem. A robot is located at the top left corner of a M cross N grid marked start in the diagram below. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid marked finish in the diagram below. How many possible unique paths are there? Now, the number of possible unique paths that are there to reach the point finish depends upon the number of possible unique paths that are there to reach the box directly above it and the box directly to its left. This is because the robot is allowed to move only down or right. Similarly, the number of possible unique paths to reach the box to the left of finish depends upon the number of possible unique paths to reach the box directly above it and the number of possible unique paths to reach the box directly to its left. In this way, we can infer that this whole problem can be divided into many subproblems that have common optimal substructure. Therefore, this problem can be solved using dynamic programming. Now, the number of possible paths that are there to reach any position on the zeroth row is 1. This is because since there is no other row above the zeroth row, therefore, to reach any position on the zeroth row, the robot would have reached that position only by moving right. Likewise, the number of possible unique paths to reach any position on the zeroth column is also 1. This is because there is no other column to the left of the zeroth column. Therefore, for any position on the zeroth column, the robot would have reached that position by moving down. But for any other position on the grid, the number of possible unique paths to reach that position is given by the sum of the number of possible unique paths to reach the box directly above it and the box directly to its left. Now translating that algorithm into code, let's declare a 2D DP array of size m cross n. Iterating over the grid. For zeroth row or zeroth column, number of ways is equal to 1. Else, for any other position, the number of ways is given by the number of ways to reach the box directly above it, as given by n-1j, plus the number of ways to reach the box directly to its left, as given by ij minus 1. Therefore, the total number of possible paths to reach the finish is given by the finish index, which is given by m-1, n-1. Running this code passes for the given input test case. Let's go ahead and submit it. Now the time complexity for the given solution is given by O of m cross n, since we iterate over both the rows and the columns of the given grid. Space complexity is also given by O of m cross n, since we use a 2D DP array. Now this problem can also be solved using combinometrics, wherein we can optimize for both space and the time. Now, the number of total rows and columns that this robot has to traverse is given by, let's comment our first approach. Total path is given by sum of number of rows to be traversed, which is given by m minus 1, plus sum of number of columns to be traversed, which is given by n minus 1, which is in total equal to m plus n minus 2, out of which number of ways to go down is given by m minus 1 rows that needs to be traversed, and the number of ways to go right is given by n minus 1 columns that needs to be traversed. Now, using the mathematical combinatorial formula of n chooses k is given by n factorial divided by k factorial to n minus k whole factorial. This can be simplified into n minus k factorial into n minus k plus 1 to n minus k plus 2 dot 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 up to n minus k plus k divided by k factorial into n minus k factorial. This can be further simplified, cancelling n minus k factorial on both numerator and denominator to have n minus k plus 1 to n minus k plus 2 dot 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 up to n minus k plus k. The whole divided by k factorial can be expanded into k minus 1 up till 2 into 1. Now, by computing the minimum of down and right and iterating up to the minimum, we can construct this final simplified combinatorial formula in order to compute a resultant number of possible paths. So, translating that logic into code, let's declare total as m plus n minus 2, and let's declare down as m minus 1, and let's declare right as n minus 1. Let's compute min as math.min of down comma right. Let's declare a resultant variable as double in order to avoid the integer overflow. And let's declare to 1 in order to compute the running multiplication. Iterating up to min from 1 calculate res as res into total minus k, which is min, plus our iterating variable I divided by I. Now returning the int cast version of our result. Running this code passes for the given test case. Let's go ahead and submit it. The time complexity for this approach is given by O of min of m comma n, and space complexity is given by O of 1. This way, using this combinatorial technique, we have optimized for both space and time complexity as compared to the dynamic programming approach. Thank you.